just going to ask it in a different manner. So a quadratic function is a second-degree polynomial. There's three forms, and we just did this in our table talk. Write down the names of each of these underneath in the blank. All right, what's the name of the first one? Y equals ax squared plus bx plus c. What do we call that? Good job. That is general form. All right, Keller, what's the middle one called? Good job. That's vertex form. And Angelo, what's the third one called? Yep, that's factored form. So you need to make sure you know all three, and you know all three forms. So you are going to have to put a little extra effort in to try to remember them. Okay, you do need to remember those. So the form of the equation we use depends on the information we have or want. So in example 1, it says use the x-intercepts to write the quadratic function in factored form. For now, we're going to leave the scale factor as a. So we're going to look at the x-intercepts. They're right here. So we're going to write the y equals a times x minus r1 times x minus r2. We actually don't know the a value. But this is what I know. I know factored form, and I use it when I have the x-intercepts or I'm told the zeros. Those are the same things. Now, we have the ability to find the a value. Okay, we have the ability to find the a value because if you look, I have another point that I'm going to call xy. So part B says substitute the x and the y into the equation we just wrote. Well, the y value is negative 2.592. I don't know a, but I know x. So grab your calculators. Okay, grab your calculators, and I want you to compute what a is. And if for some reason you don't have your calculator, you can do a split screen and pull up a Desmos to do some arithmetic on your iPad. So I'm getting A is negative 1.8. So now, once you find the A value, you plug it back in to the part A that we had. And then here is my equation in factored form. So write yourself a note. You have to find A. Okay, you have to find the A value. And so as you begin tonight's homework, which I'm hoping you'll have some time to work on it, your first step is plug in the x-intercept from a graph. Then pick a third point, not an x-intercept. Pick a third point, plug in that for x and y, and then the only thing missing is the A value. And then you go back up here and plug in that you know the A. Yeah.
Would you normally give us a third point, or would you?
Yes. Yeah. It'll either be like labeled or there'll be a dot.
Okay.
Like you can go, oh, that's 1, 4. Yeah. Great question. Great question. Okay. Now the line of symmetry for the graph passes through the vertex and the point on the x-axis halfway between the two x-intercepts. So here's the deal. Do you remember, and I have it up on that back marker board, the axis of symmetry splits the graph in half. Let me say that again. The axis of symmetry is going to split the graph in half. And so, do you understand that if it's going to split it in half, the x-intercepts, okay, if I have both x-intercepts, then that axis of symmetry is half that distance. Okay, the axis of symmetry is going to go exactly halfway between my x-intercepts. Now, here's a beautiful connection to geometry. That halfway point is like the midpoint on the x-axis between the x-intercepts. So watch what I'm going to do. I'm going to take negative 2.4 plus 0.2 and divide by 2. Whoops. But actually, I need this, sorry, let me correct myself. That, I need to know the total distance. So it's 2.4 to the left and 0.8 to the right. So that is a total of 3.2 over 2, which is 1.6, is half the distance. So now, my x-coordinate is going to be negative 2.4 plus 1.6. Which is what? Negative 0.8. So this is the x-coordinate of the vertex. Okay, let me kind of go over this again because it's a little confusing. All right, the vertex is halfway between these two numbers, okay? And so I need to know the length across the two x-intercepts. Well, it's right 0.8 and left 2.4. That is a total distance of 3.2. So then I'm going to go from negative 2.4 and add 1.6. And that's landing me at negative 0.8. That's the x-coordinate. Now, let me show you how we're going to find its y-coordinate. I have an equation in the black box. I have an equation in my black box. And if I go there, I can plug in that now I know the, let me squeeze that in there. There we go. I know the x-coordinate of my vertex, and so I can plug in negative 0.8. So let's get the y coordinate. And so use your calculators for me and do negative 1.8 times 1.6 times negative 1.6. And this will be the y coordinate of my vertex. Should it be positive or negative? What do you think? Positive, right? Because you have a negative times a positive times a negative. Two negatives will be positive. So I'm getting 4.608. So here's my vertex. So now it says, write this quadratic function in vertex form. So let's write down vertex form. I know my h and my k, and do you remember we found a already? We found the a value. So go ahead and plug those three numbers into your vertex form. Plug in your h, your k, and the a value. So here we go. That's y equals negative 1.8, x plus 0.8 squared plus 4.608. So we went from factored form to vertex form. That's what we just did. So let's talk through this one more time before we just do an extra practice problem. If I have the graph and I can see the x-intercepts, I can plug them into factored form. Pick a third point, plug in that x and y to find your a value, and now you can write factored form. You find the a value. If I want to determine the vertex from factored form, I look at the distance between the two x-intercepts, and then I take half that distance, and then you can either add it to the left side or subtract it from the right side. I could have gone from either side, it's okay. Then once you get the x-coordinate, plug it into your factored form to get the y-coordinate of the vertex. And then we already found a, so you have your a, your h, and your k. All right, questions? All right, so here's what I want you to do. Example 2 is just like this. So I'm going to give you about 4 or 5 minutes. And I want you to talk at your tables, look back through example 1, because I wrote out like what to do, and see if you can do this now in example 2. those of you on part A, first solve for A, I got 0.5 for A. If you did that, you're doing great. Okay, for A, part A, I got A was 0.5. Yay, looking good. This is awesome. Okay, I'm really hard to be patient. Don't worry, if you're a little confused, I'll work it out again. Sorry, I forgot you were going to turn it up a little. Well, okay, I'm going to do part A for those people who don't know how to do that. Those of you still working, keep working. So the first thing I would do, okay, it says you want it in factored form. So the very first thing you should write down is what's factored form. The next thing I do is I plug in my x-intercepts. So that's an x minus 1 and an x minus 5.3. Then my extra point is 0, 2.65. Again, I have this extra point, 0, 2.65, and I'm going to plug in that y is 2.65 and x is 0. So A was 0.5. So that's the answer for part A. All right, for those of you that were struggling with that one, does that make sense now? Okay, does it make sense now? That's the important part. Is maybe you're a little bit still iffy. All right, then I'm asked about vertex form. So I'm going to write this down. I know A. Okay, we know A. But we need to find the vertex. So the vertex is halfway between my x-intercepts. So write this down like if you need some advice for how to do this. Okay, well, the distance is 5.3 minus 1 over 2, which is 2.15. So then the vertex is 1 plus 2.15, or at 3.15. And that's the x-coordinate. Then find the y value. So you plug it in up here, because then the only thing missing is y. Yeah, Keely?
I guess if the distance is 3.15, right? Like the distance from the middle to the
Okay, the distance between the two x-intercepts, okay, the distance between 1 and 5.3 is 4.3. That total distance is 4.3. So I cut it in half to find out where would my x-coordinate be. That distance is 2.15 from either end. So I took 1 plus 2.15 to figure out that halfway mark is 3.15. So I did that on the last one. It's just I was on the other side. You see here that distance was negative 2.4 to 0.8, so that distance was 3.2. I cut it in half. That's 1 point, so I'm either 1.6 to the right of negative 2.4, or I'm 1.6 to the left of 0.8, and that still landed me at negative 0.8. Okay? Yeah, Davey, did you have a question? Okay. All right, so let me finish this part up. So this is going to give me 0.5 times 2.15 times negative 2.15. So the y-coordinate is negative 2.31125. And of course, we can round if we want to. So then here's my final equation in vertex form. X minus 3.15 squared. Whoops. And that's actually going to be a minus 2.3, let's say 11 is fine.